Hi, everybody. For context, this video is being recorded on March 16th, 2020. You have probably heard the expression flatten the curve in response to the coronavirus epidemic, and you may have some questions. You might be thinking, what curve? Why do we want to flatten it? What does it mean to flatten it? This video and others will attempt to address some of these questions. The graph that you are seeing all over the news is called an epidemic curve. On the x-axis is time. And time is usually measured in days since the first case is reported. On the y-axis is either the number of new cases or the total number of cases. And when I say the total number of cases, it means at that time. For this video, it doesn't matter which one we will use. It will matter in some of my later videos. Both this orange curve and this blue one are both epidemic curves. I will first discuss the curve that represents without protective measures, and then I'll describe the curve that represents with protective measures, and I'll describe what the difference is between the two of them. Before we dive into explaining the curves, there are 5 quantities that I want to explain. These 5 quantities are responsible for the shape of both of these curves. There are 2 quantities that change over time. And that is the number of people who are infected currently. The second is the number of people who are susceptible to getting infected currently. As you can imagine, both of these quantities are going to change throughout the course of the epidemic. Now, in addition to those 2 quantities, we also have 3 quantities that I'm going to think of as fixed. And fixed I'm going to put in quotation marks because there is some wiggle room here. So the first quantity is the rate that somebody who is infected and someone who is susceptible to getting infected come into contact with each other. Let's call this the contact rate. The second quantity is how infectious the virus is. This includes information such as the probability that if 2 people come in contact, the virus will transmit, and if it does get transmitted, how likely it is that it will infect the individual that is susceptible. Let's call this the infectiousness of the virus. The third quantity is how long an individual is infected for, or I should say, how long an individual is infectious for. Let's call this time infectious. So we've got the contact rate, which is really how likely it is that people come in contact with each other. And when I say people come in contact, I mean somebody who is infected comes in contact with somebody who is not. The second one, the infectiousness of the virus, is really a property of the virus. We have very little control over that at this stage. And then the third quantity is the length of time that somebody is infectious. You might imagine a scenario where this time could be reduced, but again, we are not at that stage right now. I'm going to refer back to these 5 quantities when I describe the shape of these 2 curves. So there are 3 important parts of the curve. The first part is the initial exponential phase. So the initial exponential phase is right at the beginning. And I will record another video on exponential growth and what it means. But the most important thing to remember is that exponential growth means the rate that people are getting infected is proportional to how many people are infected. That means when there's few people infected, they can, if they're each infecting so many people, then that rate at which new people are getting infected is smaller than if you have a lot of people who are infected, and they're all infecting a certain number of people. We are currently at this stage right now. And I'm going to label it the exponential growth phase. The rate of proportionality, or I should say, how steep this curve is, depends on the contact rate and the infectiousness of the virus. Notice that during the exponential phase, the number of infected individuals is increasing over time. And not only that, but it is increasing at an increasing rate. Put another way, if this was a hill you were hiking up, it is getting steeper and steeper. We are currently in this phase of the epidemic. It might be more accurate to show this curve a little bit more like that. The next phase is where the rate that people are getting infected is the highest. That means every day we would see a bigger increase in the number of people who are infected. This is because there are simultaneously a lot of people who are infected and a lot of people who are susceptible to getting infected. So it's this sweet spot where you have a lot of people who can infect others and a lot of people who can get infected. This is different than the initial exponential growth phase, where you have very few people who are infected and a lot of people who are susceptible. So let's call this the maximum rate of growth phase. It is during this phase that although the number of infected individuals is increasing, it shifts from increasing at an increasing rate to increasing at a decreasing rate. Put another way, if this was a hill, you would be at the steepest part, but it would shift from feeling like it was getting steeper to becoming less steep. Why does this happen? Why does it start to get less steep? It is because the number of people who are susceptible has decreased. That is the only reason why the curve doesn't keep growing exponentially. It is because many of the people who were susceptible to the infection have gotten infected. This is the phase where we see the number of people infected increase most rapidly. We are not at this phase yet. The final important phase is where the maximum number of infected individuals is reached. During this part, we start to see a huge slowdown in the rate that people are getting infected. This is because there aren't many people left who are susceptible. That number is so small. At the peak of cases, there are still people being infected. It just represents when the rate that the people are getting infected equals the rate that people are recovering. This is the phase where we start to feel like the epidemic is passing and getting better, but a lot of people are still getting infected. Now, to talk about the difference between these two curves, the orange and the blue. The only difference between these two curves is the contact rate. Let me try that again. Is the contact rate. When we do things like social distancing and other measures that remove us coming into contact with each other, that decreases the contact rate. And that is the only difference between these two curves. Let's kind of talk about each of the phases in our blue curve. We still have the exponential growth phase. It's just the exponential growth phase has a smaller rate of growth. The maximum rate of growth phase still exists, but notice it's much less steep. If we compare the steepness here to here, okay, the graph with the social distancing has a much flatter slope. What this means is although it is the maximum rate that people are getting infected, it's much smaller than without the protective measures. And finally, what you see about the peak is the peak is not only lower, but also longer, which means we're likely to be at that peak for a longer period of time than without the protective measures. An important point here is that the blue curve is what the epidemic looks like with sustained decrease of the contact rate. That means social distancing not just for 2 weeks, but throughout the course of the epidemic. One final note about healthcare capacity. As you can see, there's this horizontal dotted line. And what this graph is trying to show, these two graphs are trying to show, is that reducing the contact rate means that we can keep our number of cases within the healthcare system capacity. The horizontal line is an oversimplification. What happens initially is that a lot of healthcare providers become sick. This can cause a big decrease in our capacity to provide healthcare. Over time, though, we do expect the capacity to increase. This happens as more information is known about how to treat the infections and more infrastructure is built. I will be recording some more videos about these curves, including how this is connected to calculus and how to think about the model that generates these curves. In the meantime, please share in the comments section if you have any questions or would like a video addressing another aspect of this outbreak. Thanks for watching, and please feel free to share with anybody who may find this helpful.